Welcome to this explainer. We usually think of the internet as this passive series of tubes, right? Just waiting to deliver information straight to our screens. We barely even notice the massive, invisible infrastructure holding the whole shebang together, well, until it breaks. So today we're going to do a bit of a digital crime scene investigation. We are going to reverse engineer a digital roadblock. Specifically, we're looking at a very common access denied error message, the infamous Cloudflare block page. We're going to break down the exact anatomy of this block to understand the fascinating mechanics of what's actually happening behind the scenes when the internet actively pushes back against you. Look at those 5 words. Sorry, you have been blocked. Talk about a buzzkill, right? This right here is the inciting incident of our digital mystery. We've all experienced that immediate visceral frustration of hitting a digital dead end. You click a link expecting to read an article, and boom, you're instantly dropped into nowhere. But here's what's absolutely crucial to understand. This isn't just a glitch. It's not a broken link or some server that lost power. No, this is a deliberate, calculated action taken by the network. It's literally a machine making a split-second judgment about your behavior. It's a closed door, and we need to investigate exactly why the algorithm just clicked the lock shut on us. Now, what's really interesting about this slide is how the system pinpoints the exact location of our lockout, eweek.com. This zooms us right in on the exact scope of the problem, and honestly, it's a super important distinction. When you see a message like this, it doesn't mean your home internet connection went down. Actually, scratch that. It's not about your connection at all. It's a highly targeted denial of entry to this one specific domain. You are officially, at this very moment, persona non grata at eweek.com, even while the rest of the web is still perfectly open to you. So naturally, the very first thing you're going to ask is the exact question sitting right there in our source material. Why have I been blocked? And this is exactly where we shift our mindset. We're no longer just annoyed, accidental suspects standing out in the cold. We are becoming active systems investigators. We need to uncover the motive behind the machine's decision. What invisible tripwire did we just cross? What exactly did the algorithm see in those few milliseconds between our click and this error screen? Asking this question turns a totally frustrating moment into a network puzzle that's just begging to be solved. While the answer to the page gives us is incredibly revealing, it says, this website is using a security service to protect itself from online attacks. Okay, so this completely confirms that eweek.com is actively defending itself. It's like a digital fortress. Because automated bots and malicious scripts heavily outnumber actual, real human users on the modern web, these automated guards are working serious overtime. The website has essentially hired a robotic bouncer, and that bouncer has decided, based on a very specific set of programmed rules, that your current network request looks just a little too much like incoming hostile traffic. And here is where the dramatic irony really sets in. The text states, the action you just performed triggered the security solution. Wow. So it wasn't random bad luck. It was you. Your own seemingly innocent keystrokes or mouse clicks were the exact catalyst that tripped the security wire. You see, modern internet security doesn't just look for known bad actors on some static blacklist anymore. It actively looks for anomalous behavior, which means a perfectly normal person just trying to read a tech article can accidentally mimic a threat in a microsecond, prompting the system's defensive sensors to immediately drop the gate. And this brilliantly illustrates the literal rap sheet of usual suspects that trigger these defenses. Let's demystify these triggers, shall we? Number 1, submitting a certain word or phrase. This often happens if you type something into a search bar or comment field that perfectly matches a known cross-site scripting signature, basically a string of characters hackers use to inject bad code. 2, your input accidentally resembled a SQL command, which is a shady technique used to manipulate back-end databases. Or 3, you sent malformed data. Now, you might not be a hacker, but maybe you have a glitchy browser extension installed that formatted your web request in a really bizarre, broken way. That alone makes the automated guards highly suspicious of your traffic. Having firmly established the offense, the system then pivots. The next header asks, what can I do to resolve this? It's a great question, and it guides us straight from the offense to the plea. It reveals a core truth about automated security. It isn't foolproof. The system relies on a built-in appeals process because false positives, like blocking a perfectly legitimate human user, are a known and accepted flaw in the whole design. The engineers know the algorithm is going to get it wrong sometimes, so they provide a structured path for you to basically clear your name and prove that you are, in fact, a human being. Okay, let's dive into this 3-step procedure required to reach out to the site owner and appeal the block. There's kind of a bit of wry humor in the fact that you have to play detective just to read a tech article, but hey, here we are. Step 1, email the site owner directly. Step 2,
Explain exactly what you were doing when the error page popped up. Were you submitting a form, clicking a specific link? And step 3, you absolutely must provide the Cloudflare Ray ID. This step is the absolute linchpin. You can explain your actions all day long, but without that specific ID, your appeal is basically just shouting into a black hole.
Notice the specific terminology they use here regarding this required piece of trackable evidence. The text instructs that the Cloudflare Ray ID is found at the bottom of the page. Think about it. Server administrators have to sift through millions, sometimes literally billions of lines of traffic logs every single day. Finding your one specific error in that massive ocean of data? Basically impossible. So the Ray ID acts like a highly specific police incident report number. It's a unique, trackable identifier assigned exclusively to your single interaction with the server at that exact fraction of a second. It's the ultimate needle that allows them to find your event in the haystack. And right here, we see the definitive digital fingerprints left at the scene. We have our Cloudflare Ray ID on the left, 9F89C544DB06DF05. And paired right next to it, we have your specific IP address, 66.249.84.1. This starkly displays the exact relationship between you and the block. The security system has logged exactly who knocked on the door, represented by your IP address, your digital location, and the exact receipt of that denied transaction, represented by the Ray ID. Together, they form an absolutely indisputable time-stamped log entry. Let's move to and see how this builds, because we need to remind ourselves who is orchestrating this entire intricate defense mechanism behind the scenes. The text at the bottom clearly states, Performance and Security by Cloudflare. Cloudflare operates as this massive, invisible intermediary layer of the internet. They sit right between you and eweek.com, acting as a giant reverse proxy and content delivery network. They are analyzing vast amounts of global web traffic in real time, making these split-second automated decisions on who gets routed through smoothly and who gets served this exact error screen. Let's loop back to the overarching alert title of the page. Attention required, Cloudflare. The psychology of this UI design is genuinely fascinating. This isn't just some passive, quiet 404 error that fades into the background. The exclamation point makes it incredibly jarring, and that's on purpose. It demands active participation to resolve, immediately signaling that the normal, seamless, passive flow of your browsing has been abruptly interrupted. It literally forces you out of autopilot and demands you take note of the situation right now.
So the crucial point is this final bit of text. There's a vital, almost quiet instruction hidden right at the top of the source text. Please enable cookies. It acts as a lingering, almost haunting baseline prerequisite for navigating this secure internet gateway. And it makes perfect sense when you understand how security works. Cookies are how a system remembers you from one click to the next. They maintain your session state. If your cookies are turned off, you completely strip away your digital continuity. To the security algorithm, you look like a brand new, unpredictable, and therefore highly suspicious connection every single time you click. That immediately raises the threat level and can easily trigger a block before you even attempt to browse the site.
Which brings us to the ultimate takeaway of our investigation today. Are your everyday digital actions triggering the invisible security walls meant to protect the web? The internet isn't just a series of passive, open tubes. It's a living, actively defensive ecosystem, and every single click is being evaluated in real time. So the next time you see a block page, don't just get frustrated and close the tab. Recognize it for what it truly is, a transparent glimpse into the complex, automated defenses working around the clock to keep the network secure. What innocent click of yours will be the next to trip the wire? Thanks for exploring this explainer with me.